this, going back through, this is main group 1, main group 2, main group 3, main group 4, 5, 6, 7, and 8. And so those main group numbers, and I'm going to erase hydrogen here because that should not be over here for our purposes right now. So remember that the main group numbers will tell us how many valence electrons. So hydrogen is in group 1. So for group 1, all these elements have 1 valence electron. All these elements have 2 valence electrons, 3, 4, 5, 6, 7, and 8. With the exception of helium, helium only has 2 valence electrons. All right, so let's write the electron configuration for nitrogen. Nitrogen's electron configuration is 1s2, 2s2, and 2p3. When we look at this, the highest principal quantum number is 2. All right, and so when we go and look, nitrogen is in period 2. So that's the highest principal quantum number. That's the energy level that nitrogen is found in. So the valence shell for nitrogen is 2. Now when we add these two numbers, 2 plus 3 equals 5. And when you look at nitrogen, it is in group 5. Let's take a look at another one. Let's look at aluminum. Aluminum's electron configuration is 1s2, 2s2, 2p6, 3s2, and 3p1. Take a look at aluminum. It is in the third period. The highest principal quantum number is 3. When we look at the electrons in the highest energy level, 2 plus 1 equals 3. And aluminum is in main group 3. Let's take a look at calcium. Let's write the electron configuration for calcium. All right, so there's the electron configuration for calcium. The highest principal quantum number here is 4. What period is calcium in? It's in period 4. When we look at this, it does not have a P sublevel in period 4, just an S. So notice here, 2 electrons. What group is calcium in? Group 2. One more example before we move down to the D sublevel. Let's look at carbon. Carbon's electron configuration. All right, is that what you got? 1s2, 2s2, 2p2? So when we look at this, the highest principal quantum number is 2. Carbon is in period 2. When you add these electrons, 2 plus 2 equals 4. And carbon is in main group 4. Okay? So now let's take a look at an electron configuration for one that requires us to go through the D sublevel. So once again, we're going to take a look at arsenic. All right, so arsenic has an electron configuration, and I'm not saying anything because I'm giving you a chance to write it down as I write it down, so that way you can work alongside with me and I not tell you the answers. So let's write the electron configuration for arsenic. You get started ahead of me and then check and see if we have the same thing at the end. All right, check your answers. Did you remember that 3D is n-1 right here? Again, this is n-1, and so this is 3D, 4D, all right? So 3D comes before 4. Now, what's the period? What period is arsenic in? Arsenic is in period 4. Notice that is the highest principal quantum number. When you look at your S&P, 2 plus 3 equals 5, and arsenic is in group 5. So the key thing to remember here when you are identifying valence electrons based on electron configurations, the first thing you need to remember is that you want to look at the highest principal quantum number. And remember that principal quantum number, that corresponds with the period. Numbers on the periodic table. Goes with the highest principal quantum number. And then once you identify the highest principal quantum number, it will be your S and P sublevels only. No other sublevels are included when we're identifying valence electrons for electron configurations. It's always going to be the highest principal quantum number, S and P sublevel only. So again, right here, arsenic is in period 4. Highest principal quantum number is 4. When we look at the S and P sublevels only, 2 plus 3 equals 5. If we go back and look at this one right here, highest principal quantum number 2. 2 plus 3 equals 5. Again, nitrogen is a group 5. When we look at aluminum, highest principal quantum number is 3. Aluminum is in period 3. 2 plus 1 equals 3. Group 3. Calcium, the highest principal quantum number is 4. Calcium is in period 4. You have 2 electrons in the S sublevel. Calcium is in group 2. When you look at carbon, carbon is in period 2. The highest principal quantum number is 2. 2 plus 2 equals 4, and carbon is in group 4. So again, remember when we're looking at valence electrons for electron configurations or from electron configurations, you always want to make sure that you take a look at the highest principal quantum number, and you're only going to use the S and P sublevels.